All right, today's video is the best thing you'll ever learn about quadratic equations, and it is the quadratic formula. Woohoo! Hooray! I'm so excited. So, the quadratic formula is a formula that lets you solve literally any quadratic equation. So we have learned how to factor and find solutions. We've learned how to graph and find solutions. And we had to take a minute and pause, and we had to learn about radicals, and we had to learn about complex numbers, because once we understand those two concepts, we can use the quadratic formula to solve any quadratic equation whatsoever. So let's look at what the quadratic formula is. The quadratic formula is this right here. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. And I'm going to play you a song to help you get this stuck in your head until the end of time.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
Now that you have been thoroughly annoyed by the tune of that song, and you'll have it stuck in your head for 3 days, which is the goal, we're going to learn how to use the quadratic formula. So first, the equation has to be in standard form. Then we're going to identify a, b, and c, substitute them in, and simplify. So it's really pretty simple. So let's look at an example. So first, standard form. We have to set, we have to make sure that our formula is set equal to 0, or our function is set equal to 0. So we have it equal to 0, ax squared plus bx plus c. And so that means we can identify what a, b, and c are. So a is the term with x squared. That's just a 1. B is the term with x, which is 2. And c is the constant, which is negative 63. Then we substitute these into the quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And you should have been seeing that in your head along with me. So we are going to plug in, we're going to substitute a, b, and c for their variables in the formula. And when we plug stuff into the quadratic formula, always use parentheses whenever you're substituting stuff in. Negative b, which is 2, plus or minus b squared. Sorry, that's terrible. Minus 4 times a times c all over 2 times a. So the easiest thing to do is to simplify the stuff under the radical first. And this is called the discriminant, and it will determine what kind of solutions your quadratic function has. And remember, the solutions are where the function crosses the x-axis. So 2 squared is 4 minus 4 times 1 times negative 63 is going to give us negative 252. So minus negative 252 is plus 252. So that equals 256. So we're going to have x equals negative 2 plus or minus the square root of 256 over 2 times 1, which is 2. So the square root of 256, it's a perfect square. So that means that we are going to have two real solutions. And we get those. So first, let's simplify a little more. Negative 2 plus or minus the square root of 256 is 16, all divided by 2. And you can do this two ways. You can simplify here, or you can just go ahead and split this into two options. So we have the plus version and the minus version. So remember, there's almost always two solutions to a quadratic function. And the first one is going to be negative 2 plus 16 over 2. The second one is going to be negative 2 minus 16 over 2. And so these are both x equals. We're going to get negative 2 plus 16, that's 14 over 2 equals 7. So we have x equals 7. And then negative 2 minus 16 is negative 18. Divided by 2 is negative 9. And so our other solution is x equals negative 9. So the way we write our solution set is x equals negative 9, 7 in squiggly marks. Okay. So you have just used the quadratic formula to solve a quadratic function. Congratulations. On number 3, you're going to notice that this is not in standard form yet. We don't have it set equal to 0. So we need to subtract 1 from both sides, and that's going to give us negative x squared plus 2x minus 1 equals 0. And now we can identify A, B, and C. A is negative 1, B is 2, and C is also negative 1. So we are going to plug these into our quadratic formula. X is equal to negative B, and B is 2, plus or minus the square root of B squared minus 4 times A times C all over 2 times A. So first we're going to evaluate this stuff inside the square root because that is just easier. So 2 squared is 4, and then negative 4 times negative 1 is negative 4. And 4 minus 4 equals 0. So we have x equals negative 2 plus or minus, and the square root of 0 is just 0 over 2 times negative 1, which is negative 2. And if we add or subtract 0 from negative 2, that's just going to still give us negative 2. So this is really just negative 2 over negative 2, which is positive 1. So anytime that this equals 0, that means you're only going to have one solution. So the solution for this quadratic function is just x equals 1. And what that means is that our parabola is only going to hit the x-axis once, and it's going to be at positive 1. And that's the solution for that. So it would look like this. So here is another one, and we have to move the 24 over. So we subtract 24 from both sides, and that gives us 9x squared minus 25 equals 0. And we know that A equals 9, B equals 0 because we don't have a B term. And then C equals negative 25. And we're just going to plug all that in. X is equal to negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. And again, we're going to take the discriminant, that's what's under the radical, and simplify it first. 0 squared is 0, and negative 4 times 9 times negative 25 is positive 900. So we're adding 900 to 0, which is just 900. And remember that anytime our discriminant is a positive number, that means we should get two real solutions to this problem. So we have x equals 0 plus or minus the square root of 900 all over 2 times 9, which is 18. And the square root of 900 is 30. So 0 plus or minus 30 divided by 18. And the 0 is not going to change anything. So this is really just plus or minus 30 over 18. So we are going to get positive 30 over 18 and negative 30 over 18. This is going to give you 5/3 and negative 5/3. So our solution is x equals positive and negative 5/3. Plus or minus 5/3 is how you say that. Once again, for number 7, we are going to first put this in standard form. So let's subtract 4x from both sides. That's going to give us x squared minus 4x minus 9 equals 0. Now that it equals 0, we can find a, b, and c. A equals 1, b equals negative 4, and c equals negative 9. And then we'll substitute that in for our quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And these problems are why it's super important to put parentheses around everything, because if you don't square the negative as well, you're not going to get the right number whenever you do that. And then you have to have negative 4, which is positive 4. And this just helps you keep everything straight as you're simplifying. So the first thing we want to do is simplify the discriminant. Negative 4 squared is positive 16. Negative 4 times 1 times negative 9 is positive 36. 16 plus 36 equals 52. And that is a positive number, so we are going to get 2 real solutions for this quadratic equation. So we have negative 4, that's positive 4, plus or minus the square root of 52, because that's what we simplified the stuff under the radical to be. And then 2 times 1 is 2. So this is why we learned how to simplify radicals, because 52 is not a perfect square. So we're going to take the square root of 52 and we're going to simplify it by using perfect squares. So the biggest perfect square that goes perfectly into 52 is 4. So we can split this up into the square root of 4 times the square root of 13, because 4 times 13 is 52. And that's going to give us 2 square root of 13. So here we're going to get 4 plus or minus 2 square root of 13 over 2. And you see that all 3 of the coefficients or constants are divisible by 2. So we're going to have 4 divided by 2 is 2, plus or minus 2 divided by 2 is 1, so just square root of 13. And then 2 divided by 2 is 1 again, and anything over 1 is just itself. So we have 2 plus or minus the square root of 13. And any time that your answer is in radical form like this, you can just leave it as plus or minus, because we are not going to change it any further. We do not want to have the decimal version. We want this in simplest radical form, which is what 2 plus or minus square root of 13 is. So we're going to write that as a solution set. X equals the set of numbers 2 plus or minus square root of 13 in set. I've got this one and one more for you. And the last one that I do has imaginary numbers in it. So make sure you stay tuned for that one. Here we're just going to subtract 4 from both sides to get this equal to 0. We have negative 8x squared plus 3 equals 0. So A equals negative 8, B equals 0, and C equals 3. So we are going to plug it in. x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And we're going to simplify the discriminant first. 0 squared is 0. Negative 4 times negative 8 times positive 3 equals 96. So we're going to get plus 96, which just equals 96. So we have x equals negative 0, which is just 0 plus or minus, and 0 plus or minus anything is going to give you whatever that other thing is. So we can just leave the 0 off. So x equals plus or minus the square root of 96 over 2 times negative 8, which is negative 16. And the square root of 96, we need to make sure it is in simplest radical form. We can reduce it by taking the square root of 16 times the square root of 6, because 16 times 6 is 96. And the square root of 16 is 4. The square root of 6 cannot be simplified. So we are actually going to get plus or minus 4 square root of 6 over negative 16. But again, we can simplify 4 over negative 16 to be plus or minus 1 times the square root of 6 over negative 4. And any time that you have a negative in the denominator like this, let's just look at how this works. So if I split this into the two scenarios, we're going to get positive square root of 6 over negative 4, and then we're going to get negative square root of 6 over negative 4, and this equals negative square root of 6 over 4, which is fine, and this equals positive square root of 6 over 4. So if you look at this, when you have a plus or minus of something, it kind of changes the way that you look at dividing and multiplying by negative numbers. So even though this is plus or minus this over negative 4, really we can get rid of the negative because it's just going to give us the opposite sign. So x is going to equal plus or minus square root of 6 over 4. Okay, because that's the two answers that we get when we simplify. All right, our last example. Here we are already in standard form. So a equals negative 3, b equals 8, and c equals negative 7. So we are going to plug these in. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. As always, simplify the discriminant first. 8 squared is 64. Negative 4 times negative 3 times negative 7 is negative 84. And 64 minus 84 is negative 20. So notice that when we plug this back in, we get x is equal to negative 8 plus or minus the square root of negative 20 over 2 times negative 3, which is negative 6. Now, if we were in the place that we were 2 weeks ago, we would say you can't take a square root of a negative number. And what that tells us is that when the discriminant is a negative number, we are going to get two imaginary solutions. And so our solutions are going to have imaginary numbers in them, and that allows us to actually find solutions. But if you were to graph this on your calculator, it would show that it has no solutions because our calculator does not have a graph that uses imaginary numbers. So if you were to try to factor this, it wouldn't work. If you were to try to graph it, you wouldn't be able to find the solutions because the solutions to this are imaginary. Isn't that a lovely thing? So first we are going to simplify the radical. We have square root of negative 20. So the first thing that we do is separate it to square root of -1 times square root of 20. And then we know that the square root of -1 is I. And then we want to split the square root of 20 into the square root of 4 times the square root of 5. Because 4 times 5 is 20, and 4 is a perfect square. So this allows us to take the square root of 4, which is 2, multiply that by radical 5. So then when we multiply I times 2 times radical 5, or square root of 5, the proper form to write that is 2I square root of 5. And that's what we're going to plug back in up here. So we have -8 plus or minus 2I square root of 5 over -6. And we are going to divide all three of these numbers by -2. And the reason that I chose -2 is because when we multiply them by a negative or divide them by a negative, it's going to change both of these to positives, and it's just going to be prettier, to be honest. So when we divide every coefficient by -2, we are going to get 4 plus or minus I square root of 5 over 3. And that is your answer. So we're going to write it as a solution set. X equals 4 plus or minus I square root of 5 over 3. And that's your final answer. So great job, go team, go practice lots and lots of these, because the quadratic formula is something that you can use no matter what, anytime that you need it. You can always use the quadratic formula to solve a quadratic equation.